Hello students, good morning, good evening and good night depending on which time we are going to observe this lecture. In this lecture we are going to discuss again a very important topic in this chapter, that is phenol, alcohol and ether chapter, that we are going to discuss today the properties of the phenols. So heading of today's lecture is properties of the phenol. We are going to discuss different properties, that is the physical properties and chemical properties of the phenols. In the previous 5 lectures we have discussed about different topics in this chapter. That is we have discussed first lecture with classifications, second lecture we have discussed the nomenclatures, third lecture we have discussed about the properties, preparations of the alcohols, and fourth lecture we have discussed about the physical properties, and this 5 lecture we have discussed about the preparations of the phenols and identifications of the alcohols. And in the 6th lecture we are going to discuss again a very important topic, that is the properties of the phenols. So when we are talking about the properties of the phenols, it is basically relates to the structure of the phenols. We can understand the structure of the phenols composed of one, that is the hydroxyl group, and other the benzene ring. And both the places we observe there is a different types, various types of chemical reactions. In this lecture we will discuss the reactions, chemical reactions and physical properties relating to this hydroxyl group present in the benzene ring. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So physical properties, if we compare with the alcohol, what we find? We find that as alcohol make a intermolecular hydrogen bonding, in the phenol also you can observe the same thing, that it is going to make intermolecular hydrogen bonding like this. So we are discussing first the physical properties. So like alcohol, phenol is going to make a intermolecular hydrogen bonding like this. So this is the hydrogen bond between these phenol molecules, and due to this hydrogen bonding, the melting point and the boiling point of the alcohol of the phenols is much higher as compared to any aromatic hydrocarbons or haloarenes. So due to this hydrogen bonding, that you observe that melting point and boiling point is higher. For the isomeric phenols, as for example orthonitrophenol, metanitrophenol, or paranitrophenol, that we also observe a different type of trend. In the orthonitrophenol, as for example, so this is the orthonitrophenol, and in orthonitrophenol you can see there is a intramolecular hydrogen bonding. This is orthonitrophenol. In this orthonitrophenol you will find that there is a intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Intermolecular hydrogen bonding you can observe, but in case of meta and paraphenols, paranitrophenol, we will observe that the intermolecular hydrogen bonding. So if we compare the boiling point of the orthonitrophenol, paranitrophenol and metanitrophenol, what we found that in orthonitrophenol it is the boiling points is very less as compared to the para and meta, and that is why where there is a mixture of these three isomers that you can able to separate it out by steaming, by distillation process. It is steam volatile. That means orthonitrophenol have the very less boiling point, so it can be steam volatile and you can able to separate out from other isomers. So we understand the boiling point and the melting point of the phenol is higher as compared to the other hydrocarbons, the aromatic hydrocarbons, and orthonitrophenol having the least boiling point because of the fact it has the intramolecular hydrogen bonding. What is, first we have discussed, that is the boiling point and melting point. Second, that is we are going to discuss the solubility. Solubility of phenol as it's found the hydrogen bonding with the water, so its solubility will be higher, solubility will be good. But if we compare with the alcohol, what we found, the alcohol have the greater solubility. Alcohol, you can write alcohol have greater solubility, have higher solubility as compared to the phenol, as compared to phenol. Because of the fact phenol has the larger hydrocarbon part, because it is having the alcohol is like this, suppose C2H5OH, and the phenol you can see that it has a benzene ring attached to it. This is phenol. So this portion is higher than this portion. That is why the solubility of the phenol is less as compared to the alcohol. Okay, so you understand the physical properties. Now we are going to discuss the chemical properties of the phenol. Chemical property, when we are talking about it, that it basically divides into two parts. Number one, the reaction involved only in the OH group. Number one. Number two, that is another where the reaction taking place at the benzene ring itself. So in this lecture we will discuss only those reactions which are concerned, which are basically we will find in terms of the OH, that is a hydroxyl group, the reaction taking place in that hydroxyl group. When we are talking about the chemical reactions, if we compare with the alcohol, what we found, there is a different type of relationship, or we can say there is a lot of difference in some chemical properties. First, that is for the chemical properties we are talking about. So we are discussing the chemical properties. Chemical properties, first thing, if we want to differentiate, if we want to see the difference between the alcohol and the phenol, what we found, first thing that we observe, the acidity of phenol, is higher than alcohol, and that is why you can observe that blue litmus paper has been transformed into the red with the phenol. When we give a touch of phenol in this blue litmus paper, we found that it will be turned into red. But this is not happened in case of alcohol. Another thing, another experiment that we can see, that phenol C6H5OH can react with the NaOH and it is produce the sodium phenoxide. Whereas the alcohol with NaOH, there is no reaction. This also proves practically that alcohol have the lesser acidity as compared to the phenol. Why it is so? If we want to understand why it is so, why phenol having the higher acidity as compared to the alcohol, it is because of the fact the alkoxide ion, the negative charge in the alkoxide ion, so we need to understand is ROH. When it is ionizes, it will create alkoxide ion and plus H plus ion. And in case of phenol, it will create phenoxide ion and H plus ion. Here the negative charge with rest on this oxygen atom in case of alkoxide ion, it is totally localized. So its stability is not much as compared to this phenoxide ion, where this negative charge is delocalized by resonance, because we know benzene ring has the alternate double bond and single bond. So this negative charge will be localized, delocalized, dispersed throughout the ring. So this is very stable. So if it is stable, then this forward reaction is going to be perceived, and it is so stable, it is more stable than the phenol itself. So alkoxide, due to the stability of the phenoxide ion than the alkoxide ion, the acidity of the phenol is higher as compared to the alcohol. So first point, that is the acidity of the phenol is higher than the alcohol. Next point, that is very important point, that is we need to know. Second point, when we are comparing with we are differentiating the chemical property of the alcohol and phenol, that is the COOH bond in alcohol can be easily breakable. You can easily able to break, but in case of phenol, that you cannot able to break, because of the fact there is a double bond character, partial double bond character in this bond, because there is a resonance between the oxygen molecules, with the OH group and the benzene ring. So because of this, there will be the partial double bond, and this cannot be easily break. Third point that we need to understand, that is the elimination reaction that we observe in case of, we write it, elimination reaction. Elimination reaction that we observe in case of phenol, in case of alcohol, is not possible elimination not possible in case of elimination reaction, that is in case of not possible in case of phenol. And fourth point, the oxidation product is totally different. The oxidation product of the phenol is totally different from the alcohol. Oxidation product is different. So we understand the difference between the phenol and alcohol. Oxidation product is different. Though there is a difference between the chemical reactions if we compare with the alcohol and phenol. Okay. Now we are going to discuss different type of chemical reaction that has occurred in the OH group of reaction. Different types of reaction. First reaction, that is the reaction with active metal. Reaction with active metal. Active metal means sodium, potassium, aluminum, those are active metal. So this reaction you can see C6H5OH. This reaction is basically being carried out with this OH group. Here is you can see there is the breaking of the OH bond, and this is going to create the sodium phenoxide. Sodium phenoxide, and there is a evolution of hydrogen. We are balancing it. This is a balanced reaction, you can see. This is the reaction with the metal, and this proves the acid property of the phenol. Second that we are going to discuss, that is alkylation. Alkylation reaction. Alkylation. Alkylation, in this reaction, the reaction is carried out with the sodium phenoxide. Sodium phenoxide with the methyl iodide, and when we heat this reaction mixture, it will going to produce a ether, CH3O CH3, and you will produce, you will see, NAI, and this name is of this product is anisole. Another reaction, C6H5ONa plus C2H5I. When we heat this, it is going to prepare C6H5O C2H5 plus NAI, and this is now phenitol. So these two products with the alkylations. Number 3 product, that is acylation. Acylation reaction. Acylation is basically the reaction where you find there is an incorporation of CH3CO group. This acylation reaction, you can see C6H5OH phenol plus acetyl chloride, and it will, the reaction is carried out in presence of pyridine. This is a base, and it will going to create this C6H5CO CH3O CH3 plus HCl, and this is called phenyl acetate. This reaction also being carried out with the acid anhydride. In presence of the pyridine, same thing, that you will find here C6H5O COCH3 plus CH3COOH, acetic acid. Phenyl acetate and acetic acid, and you can see here this H atoms has been replaced. H and Cl atom has been eliminated, and it is being produced HCl, And this is, in this process you also find that is, you can see there is a breaking of this OH bond, and this type of reaction that you can see also in case of alcohol. Fourth reaction, that is benzoylation. Benzoylation. In this reaction, the reaction is carried out with phenol and benzyl chloride, with benzyl chloride, CCH5COCl, and it will going to produce this phenyl benzoate. It will going to create the phenyl benzoate, CO C6H5 plus HCl, and reaction is carried out in presence of NOH. NOH is a base. It will just react with the HCl, and the reaction will be carried out unidirectionally. So this is the benzoyl reaction. Fifth reaction that we are going to discuss, that is again a very important reaction, that is the distillation with zinc. Distillation with zinc dust. With zinc dust. This is reaction, you can see C6H5OH plus zinc, and when it is heated with zinc dust, when it is heated, it will going to produce benzene plus ZnO. Okay. Now sixth reaction, reaction with Grignard reagent. Grignard reagent. Suppose Grignard reagent is CSR MgBr. This is Grignard reagent. RMgBr. Now we can say RMgX. RMgX plus C6H5OH, and it is going to produce RH plus C6H5OMgX. So in this process you can find, you can able to produce the alkane, the alkyl group in which the alkyl group present in the Grignard reagent. Seventh reaction, the reaction with halogen acid. Halogen acid and phosphorus halide. This reaction we have observed in case of alcohol also, but here, as because of the fact CO bond is very strong because of the resonance in the benzene ring, there is a double bond character. So this cannot be broken. So here, the like alcohol, we will not find this type of reaction. We will find the reaction is like this, different type of product, that CCH5OH plus PCl5. It will going to produce CCH5 So you can see this is triphenyl phosphate. Triphenyl phosphate and chlorobenzene. Small amount of chlorobenzene you can observe, and majority is the triphenyl phosphate. So when this react with this, you will find the triphenyl phosphate and this. Okay. Now again the reaction with FeCl3. In FeCl3, reaction with FeCl3, it will produce, this is the characteristics reaction, that if you want to distinguish between the alcohol and phenol, at that time if we give some FeCl3, you will find that there is a characteristic reaction in the phenol and it will produce a green color effect, green coloration. From this we can able to understand that there is a presence of the phenol. So ninth reaction, that is the reduction of phenol. Reduction of phenol. In this case, you will find that C6H5OH, when it is reduced at the temperature 533 Kelvin, and reduction is the catalytic reduction in presence of nickel, and when you reduce it, it will going to produce this product, that is cyclohexanol. This is going to produce the cyclohexanol. Okay. All for today's lecture. In this lecture, we have discussed about the physical and chemical properties of the phenol, and those chemical properties that we have discussed, which concerned with the reaction with the OH group only. And the next lecture we are going to discuss the reaction which involved in the benzene ring, that is the electrophilic substitution reactions, and we will understand how electrolytic substitution reaction is carried out with the mechanism. So thank you very much for watching this lecture. If you like this lecture, you can share to your friends, and we will meet in the next lecture. Thank you.